All right, so today we're diving into a really cool university project. It's all about how you can take something as simple as a laser pointer and turn it into a high-tech communication device, one that can send music, text, pretty much anything, right through the air on a beam of light.
Okay, so let me ask you a question. What if you could send a message to your friend across a packed room? Totally silent, totally secure, and nobody else has a clue. Sounds like something out of a spy movie, right? Well, it's not. It's the real idea behind the technology that a couple of engineering students brought to life. Okay, let's get into it. So how did they pull this off? First, we got to get our heads around the basic tech they're using. It's a field with honestly a super cool name. Free space optics.
Free space optics, or FSO, is really just a fancy term for sending data through the air using light. You know fiber optics, right? Where data zips through glass cables at light speed? Well, imagine that, but without any cables at all. The cable is just thin air.
Okay, so the big question is, why bother with light when we've got Wi-Fi and Bluetooth everywhere? Well, there are some huge advantages. For starters, it's wildly secure. Think about it. A laser beam is super focused. You literally have to be standing right in its path to even have a chance of intercepting it, unlike radio waves that just go everywhere. It's also completely immune to all that radio and electrical noise that can mess with your Wi-Fi. But here's the real kicker. Especially for a DIY project, the parts are dirt cheap, and you don't need any special government license to use.
So with that in mind, let's get to the project itself. How do you actually go about building one of these laser links with stuff you can just buy online? Well, let's meet the students who did exactly that.
So, this whole setup, it was designed and built by two students, Ms. 𝗖𝗺𝗺𝗂𝗂𝗧 and Abdullah Atif at the Bangladesh University of Engineering and Technology. I mean, this is just a perfect example of taking what you learned in a classroom and making something real, something that actually works.
Now this is where it gets really cool. Just look at this hardware list. These aren't some crazy, expensive, hard-to-find parts. You've got an ESP32, which is kind of the brain of the operation on both ends. A regular laser diode is the mouth sending the light, and a tiny solar panel acts as the ear to detect it. And I love this part. They used an L293D chip, which is usually for making motor spin, as a super fast on-off switch for the laser. So clever.
Okay, get ready for this, because this number is just wow. The total cost for everything they needed to build this entire system, according to their report, it was about $25. $25. For that price, they built a wireless data link. That is just incredible.
And the cleverness just keeps on coming. This thing isn't a one-trick pony. The whole system was actually designed to handle two fundamentally different types of information. You've got your smooth, analog sound, and you've got your precise, digital data.
And here's how they managed to send those two totally different kinds of information. For audio, they use what's called amplitude modulation, or AM. The dimmer switch analogy is perfect. You're just making the laser get brighter and dimmer, perfectly matching the ups and downs of the sound wave. But for text and data, that's totally different. They use something called on-off keying. Think of it like Morse code on hyperdrive, just flashing the laser super fast, on for a 1, off for a 0.
So let's break down how it sends something simple, like the letter A. First, the transmitter's little brain, that ESP32, turns the letter A into its binary code, a string of 8 ones and zeros. Then, bam, it flashes the laser in that exact pattern. Across the room, the little solar panel sees those flashes and turns them back into electrical signals. And finally, the receiver's brain reassembles those pulses and puts the letter A right up on the screen. It's so simple, but it works.
All right, so the theory sounds good, right? The parts are cheap, but the real question is, did it actually work? Let's take a look.
And yes, it did. I mean, look at this. This is right from their report. The receiver screen is clearly showing one of the students' names, sent completely wirelessly over that light beam. That is a huge win. But they didn't just stop at text. They also hooked up a temperature sensor to the transmitter side. And sure enough, the receiver was able to show live temperature readings, which proved the system could handle live, changing information, not just static messages. And then, to really show what it could do, they even used it for remote control. They added a simple knob to the transmitter, and just by turning it, they could wirelessly change the brightness of an LED on the receiver. So now you've got remote control too, all over that same light beam.
You know, they really summed it up perfectly themselves in their report's conclusion. They wrote,
This project successfully implemented a low-cost, efficient, and educational system for free space laser communication. I mean, they nailed it.
But, this stuff is never as easy as it sounds. And to their credit, the report is super honest about the problems they ran into. Getting that laser aimed perfectly was a nightmare. The slightest nudge and poof, the connection's gone. Sunlight, even bright indoor lights, would create a ton of noise and confuse the receiver. They also found that cranking up the audio too much caused distortion, and they really had to fine-tune the timing of the digital pulses, because if it was off by just a tiny bit, the data would get all scrambled. The fact they got it working despite all that just makes the whole thing even more impressive.
So, okay, they proved it can be done, and done cheap. What's next? Where can this kind of technology go from here? Well, a project like this really opens up a ton of possibilities.
Well, the possibilities are actually pretty huge. You could set up totally secure data links between, say, two windows in different buildings without having to dig up the street to run a cable. Or what about a home audio system with absolutely zero interference from your Wi-Fi or microwave? Perfect. It's an amazing teaching tool for physics classes, and you could even use it for security, like a high-tech laser tripwire.
And there's a clear roadmap for making this thing even better. For starters, you could add error correction code to make the data more reliable, even with some interference. You could also make it a two-way street by putting a laser and a detector on both ends. And if you really wanted to crank up the speed, you could swap out that solar panel for something called a pin photodiode. Heck, you could even add little motors to make the whole thing aim itself automatically. How cool would that be?
What's so great about this project is that it takes this really advanced sounding idea and shows us that, hey, you can build this at home with a little bit of code and some cheap parts. So I'll leave you with this question. Now that you know the basics of how it's done, what would you send on a beam of light?